24 hours a day.
Tornadoes, a phenomenal force as well as a deadly one. How do they form, and where are you most likely to see this destructive example of nature's fury? The answer's coming up in tonight's Violent Skies.
And March continues its lion-like entrance with snow and rain from New Mexico to the Northeast. Is winter back for another round? Details coming up on the Weather Channel.
Spring storms give way to winter's return. Good evening, I'm Lisa Spencer.
And I'm Jeff Morrow. Even though snow dominates the weather picture tonight, this is the season when thoughts turn toward severe weather. Every year, people are killed and property is destroyed by one of nature's most destructive forces. In tonight's edition of Violent Skies, we take a closer look at tornadoes.
Tornadoes are the most violent of all the storms on Earth. They produce winds that can exceed 300 miles an hour. Tornadoes occur in many regions around the world, but in total number of storms, the U.S. leads the way. 1,167 were reported across the country in 1993. The largest percentage occur in the infamous area known as Tornado Alley, a region in the Plain States. Texas, on average, reports 123 tornadoes a year. Oklahoma, 53, and Kansas, 42. Storms concentrate in this area because of a unique combination of weather conditions and topography. Typically, in spring, a low-pressure system pulls out into the plains. This is accompanied by a warm front, cold front, and sometimes the boundary between moist and dry air, known as the dry line. Brisk winds in the lower atmosphere, the low-level jet, blow up from the Gulf of Mexico, supplying energy and moisture. The jet stream in the upper atmosphere races overhead at speeds in excess of 100 miles per hour. This brings in energy and dry air aloft. Finally, cold air aloft pushes east, and the atmosphere becomes unstable. Add all these ingredients together, and the environment is primed for severe thunderstorms and tornadoes. Tornadoes evolve because of certain elements. Wind shear, winds at different altitudes blowing in different directions, causes the air between the layers to begin spinning, almost like a horizontal tornado, although not nearly as fast. When this horizontally rotating air meets an updraft, the rotating tube can become stretched and tilted. As the now nearly vertical tube tightens its spin, it speeds up. The result, a tornado that has the potential of causing loss of life and extensive property damage. In Andover, Kansas, portions of the town were flattened by a twister in April 1991. 13 people were killed, another grim reminder of the power of one of nature's most deadly forces. I'm Charlie Welsh, the Weather Channel.
As we have just seen, tornadoes can cause death and great destruction. The amount of destruction usually depends on the strength of the tornado. Just as hurricanes are categorized by force, so are tornadoes by something called the Fujita scale. If a tornado is classified as an F0 or an F1, it is considered a weak tornado. F1 tornadoes have winds up to 112 miles per hour and can do roof damage and can throw cars from roads, and some mobile homes can be torn apart. Now, as far as an F2 or an F3 tornado, they're considered to be strong with winds as high as 206 miles per hour. Even then, on an F3, strongly built buildings, outside walls are blown away, and weaker homes are completely swept away. And violent tornadoes are classified as F4s or F5s. These are probably the rarest tornadoes. They don't occur very often, but when they do, the destruction is tremendous, with winds estimated up to 318 miles per hour. Strongly built homes completely blown away, and if you've ever seen destruction from an F5 tornado, all you see left is the foundation. Now, severe thunderstorms also have a criteria to be considered severe. A storm must possess winds exceeding 58 miles an hour, have hail 3/4 of an inch or larger, and sometimes have funnel clouds or tornadoes. In all severe storms, you want to be safe, but especially during this tornado season, remember, go to an interior room on the lowest floor If you're in a mobile home, don't stay there. If you can, try to get to a more secure shelter area. If outside in a vehicle, take shelter in a ditch or perhaps underneath an overpass. In tomorrow night's segment of Violent Skies, we take a trip to Kansas City to see what steps are being taken in the role of forecasting tornadoes. Now, we don't have a lot of severe weather to talk about tonight. Snow is more the problem.
You can always turn to for accurate, dependable weather forecasts 24 hours a day.
The following program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
Whoa! Holy cow! Oh, the weather classroom.
And once again, thanks for joining us here in the Weather Classroom. Mike Seidel with Dennis Smith. Today's focus, the greenhouse effect. There's a lot of talk over recent years about what's going on. Are temperatures actually warming up because of the greenhouse effect, or is it just one of those little blips on the old climatic graph over periods of hundreds and hundreds of years? We'll have more on that in just a moment. Later on, in our closer look, Dennis looks at severe weather awareness. Again, this is springtime, the prime time for severe weather, tornadoes, large hail, wind damage, and we've got some severe weather today, and we'll talk more about the states that are going through their motions, taking severe weather very seriously this week. First, though, let's talk about the greenhouse effect and global temperatures. The greenhouse effect is basically just the warming of the Earth because of the trapping of gases, trapping of the radiation by gases in the higher levels of the atmosphere. For instance, carbon dioxide and water vapor are higher up in the atmosphere, and as radiation or heat escapes the Earth, it rises. Now, some of that gets trapped by the carbon dioxide, and that's good because it keeps the Earth from cooling down, unlike the moon, which has no atmosphere and is very cold every night, and there's a huge rise and fall in temperatures from day in to day out. Now, looking back 100 years, it looks like we've had a warm-up, according to this graph, by about 1 degree worldwide. Again, carbon dioxide, one of the major gases that contribute to the greenhouse effect because of the exhaust from cars and the burning of fossil fuels such as oil and coal and natural gas. Again, that escapes up to the Earth, and that ring, that atmospheric ring, continues to kind of trap the heat. We need some of the trapping of the heat, but we don't need as much as we may be getting over recent years. Again, methane is another one of those gases that contributes to the greenhouse effect, either from cows or the burning of forests. And again, forests are very important in absorbing carbon dioxide, and when we lose our forest or the rainforest, we lose one of our sources of kind of eating up that carbon dioxide. Here's the greenhouse effect as a whole. Again, we have radiation coming in every day from the sun. In the evening, that radiation goes back up to space. Some of it's trapped, but if it's too much of it's trapped, then the Earth continues to warm. How about more on the greenhouse effect? Let's get that from Dennis Smith.
There's a certain quantity of greenhouse gases in the Earth's atmosphere all the time. They allow sunlight through to warm the surface of the Earth. They also prevent some of the heat from escaping into space. So they've helped keep the Earth's surface at an average temperature of 55.4 degrees Fahrenheit for thousands of years. But since the dawn of the Industrial Revolution in the early 1800s, greenhouse gases from industrial burning have increased by 30%. That means that while sunlight still enters the atmosphere, less heat can escape. The more greenhouse gases, the warmer the Earth will grow, theoretically. This computer model prepared by the Goddard Research Institute projects the warming to be as much as 5 degrees Celsius in some areas. This projection is not universally accepted, but most scientists agree there will be some warming in the next 50 to 100 years.
Again, as Mike was pointing out, influx into the atmosphere from carbon dioxide sources are basically cars and the burning of fossil fuels. Also, another thing of concern of recent decades has been the introduction of CFCs, or fluorocarbons. And Once again, that is a problem as generated from freon in refrigerators, freon found in home air conditioners, and freon found in car air conditioners. All those come together to have an influence as far as our atmosphere structure and how much of that warming that may come to play in heating up the atmosphere around the globe and actually raising the global temperature a little bit. Here to find out more is Jeff Morrow.
Carbon dioxide is deposited in the atmosphere when we burn fossil fuels such as coal and oil. Once in the atmosphere, the CO2 acts much like the glass of a greenhouse, allowing in the warming rays of the sun, but not letting the heat escape. Normally, the carbon dioxide would be absorbed by our oceans. Here at Scripps, they test both air and seawater for CO2 content. Glass globes filled with air samples from around the world are carefully prepared and tested. And the indications are we've been pouring CO2 into our atmosphere at a rate far faster than our oceans can withstand.
I think it's fair to say, based on our knowledge, that the carbon dioxide is at the highest level since the human race showed up. It's almost a certainty that no time in the past did the atmosphere change as rapidly as it's changing now.
Indeed. Of all the CO2 increase since the start of the Industrial Revolution, half of it has taken place since Dr. Keeling began his measurements just 30 years ago.
Well, the answer was Brazil, and Brazil is one area where there are a lot of rainforests. Rainforests play a very important role in the stabilization of the Earth's climate. Here, once again, is Jeff Morrow with more.
Rainforests, often called the lungs of our planet, are being destroyed for timber, for fuel, to make way for farming, and most disturbing of all, for cocaine production. Estimates of the rate of tropical rainforest destruction range from 47,000 to 135,000 acres every day. When rainforests are cut down, not only do we lose a way to process carbon dioxide, one that took millions of years to develop, but exposing the virgin soil along with the burning of the cleared timber releases 36 billion tons of carbon dioxide into the atmosphere every year. As more greenhouse gases are poured into the atmosphere, Earth's climate grows warmer, sea levels rise yet higher, drought becomes the norm. And if we continue at our present rate of warming, all this could come true not in some distant science fiction future, but in just 50 years. Disturbing to think that the destruction of a rainforest in Brazil could cause New York to become as warm as Nashville. Now that's cause and effect.
Kind of shifting gears as we settle into Severe Weather Awareness Week this upcoming week for Kansas and Texas, favorite areas as they move into the early spring and eventually the late spring months, where favorite areas for severe weather development starts to juvenate up in those areas. Now, one part of the country, and specifically Kansas City, Missouri, is the national headquarters for forecasting severe weather and narrowing it down to what you see, those little boxes that we have on the air. The National Severe Storms Forecast Center. Here's more.
With it, but we are still watching this large dry area moving eastward across Texas, and that appears to be enhancing some thunderstorm activity. We have focused in for a slight risk of severe thunderstorms from southeast Texas across parts of Louisiana into Mississippi.
Meteorologists at the National Severe Storms Forecast Center keep up to date daily on the potential for severe weather. The forecasters analyze the latest weather data for the whole country, hour by hour, minute by minute. They use the latest satellite imagery, local radar, and observations from regional weather offices.
We are somewhat of a detective in that we have to search through a lot of different clues. We have information to tell us what it's like right now, but we have to try and figure out what it's going to be 6 hours from now, and that is the real challenge that we face.
Good to hear this. I'm not sure that this is going to move that much.
Right. Or if they observe an area where severe weather has the potential to form, the office issues a thunderstorm or tornado watch. This is transmitted to the local National Weather Service office, which in turn issues the watch to the public. Tornadoes are killers, but in recent years, the death toll from these storms has been reduced by 50%. 10 years ago, only half the major tornadoes were preceded by a watch or a warning.
Now, in the early 1990s, thanks to more experience by the forecasters and the modern technology, we're close to 90% now. That means, and we think that's a given the degree of difficulty, that's a good track record.
An accurate and timely forecast is vital because the more information the public receives, the more time they have to react and take the necessary safety precautions. I'm Charlie Welsh, the Weather Channel.
Again, a twofold subjects today, greenhouse effect, the first half, and if you want to know more about greenhouse effect, we refer you to Chapter 13 on climate and climate change. And if you want to find out more about what's going on in severe weather and how you need to be prepared for the upcoming severe weather season, we continue with our series of violent skies through the week of March 7th to the 11th. You can tune into the Weather Channel at 7:30, 9, and 9:30 p.m. Eastern Standard Time to find out the very latest on our series on violent skies.